Dr. Ajit, maybe we'll start now.
Yes, Jenny, we can start. Good morning, everyone, and I welcome you all to the masterclass on sample size calculation in medical research studies using the software G Power. And guys, as this 3 hours masterclass is to provide the participants with an in-depth understanding of sample size calculations in the context of medical research studies using the versatile free-to-use tool G Power software. The class will cover the theoretical concepts, practical aspects, and hands-on exercises to enhance the participants' proficiency in determining the optimal sample sizes. Right, guys? I'll not delay. I'll introduce our today's resource person. We have with us Mr. Jenny Raja Singh. He is BTech in biotechnology, and he has done multiple courses in AI and statistics. He is expert of that, and he's working right now in GSK as the special biostatistician. Without a delay, I'll hand over the session to Mr. Jenny. Go ahead, please, Jenny, and I welcome you all again. Thank you, Jenny. Thank you, everyone.
Thank you, Ajit. Okay, I'll share my screen. Uh,
Yes, it is visible. Please make it full screen and go ahead.
sure. Also, Dr. Ajit, let me know if there is any audio issue. Please interrupt me. So I will.
Sure. No, it is right now. It's good. Please just make the full screen and please go ahead. Yeah, thank you.
Okay. So we will see today's master class. We will see sample size calculation using G power. So first we will see the theory, what is sample size, and then we will see what are all the factors influencing sample size. So we will see sample size calculation for observational study, and also we will see sample size calculation using interventional study. Once the theory is over, we will see how to run the sample size calculation in G power for both observational study and interventional study. So first we will see the theory. First we will make ourselves strong in theory. Then we will go to practicals. Okay. So first we will see what is sample size. So even if it is observational study or interventional study, sample size means the number of participants or observation need to be included in the study. We will see some example. Imagine a study. Imagine a clinical trial. There is a new drug for treating a cardiovascular disease. So pharma company decide to calculate the sample size. If they decide a sample size as 10, they might miss a true effect of the drug because if the drug is slightly less effective than the current treatment. Uh, for example, it is like taking a single blood pressure reading. It doesn't capture the full picture. For example, if you are taking only single subject for a sample size, imagine he is 60 plus years old. The age may be a confounding variable, or gender may be a confounding variable. So whenever your sample size is less, the confounding variable may have an impact in the true effect of the drug. So whenever you are having a small sample size, your results may be impacted by the confounding variables. Okay. So but if the sample size is very large, then your readings, maybe you are like taking a reading throughout the day, giving you a clear understanding of the drug true impact. You can detect even a subtle difference, and even if the difference between drug and placebo is a minor, you can see the true effect through the larger sample size. So whenever the sample size is small, the confounding variable may have an impact in the result. But when the sample size is huge, even if there is a minor difference between the true treatments, your large sample size give you an accurate result. Okay, but there are some even though the large sample size give you the accurate result, but there are sometimes a disadvantage also. Whenever you are going for a large sample size, there may be a huge cost and huge time. Okay, and also there is a increased chance of false positive. Whenever there is a huge amount of subjects involved in the study, there may be some noise, there may be some chance of false positive. We will see what is false positive in the upcoming slides. Okay, so this is the disadvantage of large sample size. Okay, so in order to avoid this issue in observational study or in clinical trial, interventional study, the researcher want to get a optimal sample size. How we will calculate the optimal sample size? We will use the statistical method. We will use some statistical technique to find the optimal sample size for both observational study and interventional study. Okay. Uh, Okay, so before going to the sample size calculation for observational study and interventional study, you should understand some statistical concept. Otherwise, the when you see the sample size formula, you may get confused. So you should, before going to the sample size calculation formula, you should understand some basic statistical terms. The first one is confusion matrix. Uh, so the first image is showing the matrix. So in left side, it is showing the actual values, and right side it is showing the predicted value. Consider uh, there are 165 subjects are there totally. Out of 165 subjects, some people are having a fracture, some people are having a sprain, some people are having some minor injury, but they are coming to a hospital to take a X-ray. So why they want to take a X-ray? They want to confirm they have a fracture or not. So the actual is nothing but the whether the subject is really having a fracture or not. The predicted is something like the what is the X-ray result. X-ray result is telling whether the subject is having a fracture or not. So the left side actual column says that whether the subject is really having a fracture or not. Predicted is something like the X-ray report, whether the X-ray report says whether the subjects are having a uh, fracture or not. So what this confusion matrix tell us, uh, what this confusion matrix tell us whether we are going to test how the X-ray results are, okay, whether the X-ray results are valid or not. How we can find whether the X-ray results are valid or not? We will see how many are true negative and how many are true positive. So, for example, in this matrix, if you see, there are nearly 50 subject doesn't have the fracture. Okay, but under the category predicted no. But in the when the X-ray report says fracture yes, there are 10 participants. So first you understand the matrix structure. Actual no or yes means whether the subject is really having a fracture or not. Predicted means whether the X-ray report says whether the subject is having a X-ray fracture or not. So in this, if you see, there are 50 subjects falls under the true negative category and 100 subjects falls under the true positive category. True positive means 100 subject is really having the fracture and X-ray report also says the same. True negative means 50 subjects are not having the fracture and it is also visible in the X-ray report. False positive means uh, in X-ray, 10 participants showing as a fracture, but in actual, the 10 doesn't have the fracture. Okay, they may have some sprain or minor injury. And if you see false negative, 5 people X-ray report show us no, but the but as per the actual report, they have the fracture. Okay. So using this confusion matrix, we will calculate some accuracy, precision, and type 1 and type 2 error. So maybe I will explain why this is needed for the sample size calculation. So confusion matrix, this is one of the basic concept for sample size calculation. Type 1 error means false positive, type 2 error means false negative. Okay, now we will see what is accuracy. Accuracy is the ratio of correctly predicted labels to the total predicted labels.
So
So,
your voice is lagging a little bit.
sorry, my voice is not audible.
It's lagging, sir. It's like lagging.
Okay. Uh, Ajit, can you confirm everyone faces the same issue?
No, sir. No, sir.
Okay, then maybe check your internet connection. Okay. I
It's
don't know.
completely okay, sir.
Okay, maybe check your internet connection, maybe rejoin once again. Now you may not have that issue. Okay. Okay, we will see what is accuracy means. Accuracy means the ratio of correctly predicted labels to the total predicted. Accuracy means nothing but how many are correctly predicted in the X-ray report. How many are correctly predicted in the X-ray report? So what you have to do is you have to add true negative plus true positive. True negative is 50, true positive is 100, divided by total number of subjects. So in our true negative plus true positive is 110 divided by 165, that comes around 90 percentage. So accuracy is 90 percentage. That means X-ray is correctly predicted the fracture 90 percentage. 90 percentage of time X-ray predicted the fracture correctly. And then we will see what is Precision is nothing but the ratio of number of actual S's correctly predicted to the total number of predicted S. So among the total predicted S, how many are correctly predicted? So what you have to do is add total predicted means true. In denominator, you have total true positive and false positive, and in numerator you have only true positive. So here the precision is 91 percentage. Okay, so what that 91 percentage is, how many times X-ray predicted correctly among the denominator of total number of predicted is. Okay, so accuracy is in denominator you will have the total number of subjects, but in precision you in denominator you will have only the total number of predicted S's. Okay, that means the X-ray how many times it predicted as fracture. Okay, so accuracy and precision you should know the difference. And there is one more example. This is the example for pregnancy. Uh, Predicted pregnancy versus actual pregnancy. So here, if you see, the type 1 error is the false positive conclusion, and type 2 error is the false negative conclusion. So a type 1 error is nothing but what is the error involved in your confusion matrix, type 1 and type 2 error. Okay, if it is type 1, it is a false positive. If it is type 2, it is a false negative conclusion. Okay. So I will again repeat this. This is very important concept in sample size calculation. Accuracy means how many times the X-ray predicted the fracture correctly. Precision means how many times X-ray predicted the fracture correctly among the total number of predicted fracture. Type 1 error is nothing but the false positive, and type 2 error is the false negative. And then we will go to the confidence level. One more important parameter for sample size calculation is confidence level. Okay, so the confidence level is the probability that a statistical estimate falls with a specific interval. It is often expressed as the percentage. Commonly you will see 95 percentage or 99 percentage. Okay, so if you are selecting 99 percentage confidence level, that means your whatever results you will be getting, like prevalence. If you are going for an observational study, you will measure the prevalence, right? Suppose if you are going for a clinical trial, you will see the mean difference between the two treatments, like vaccine versus placebo. You will see the effect size. So the statistical estimate is nothing but the prevalence or the mean difference. When you are calculating the statistical estimate, how much confident you are. Okay, suppose if we are selecting 99 percentage confidence level for sample size calculation, then you will have a 99 percentage confidence that your results will be accurate. Okay, I will again repeat. If you are selecting a 99 percentage confidence for a sample size calculation, your future statistical estimate, like prevalence or mean difference, will be 95 percentage accurate. Okay, uh, okay, suppose if you are selecting 95 percentage confidence level, it implies that if you are conducting a same study multiple times, we would expect the true parameter to be within the calculated interval in the 95 percentage of the study. Okay. So, for example, when you are conducting an observational study, you want to find the prevalence of diabetes mellitus, and you are for sample size calculation, you are fixing a 95 percentage confidence level, and then you are getting a prevalence value as a 67 percentage. For example, if the prevalence of diabetes mellitus is 67 percentage, then you can say that we are 95 percentage sure that the prevalence of diabetes mellitus is 67 percentage. Okay. Okay, and then we will see confidence level and type 1 and type 2 error. There is some connection between the confidence level and type 1 and type 2 error. Type 1 and type 2 error is nothing but false positive. Type 1 is false positive from confusion matrix. Type 2 error is a false negative from the confusion matrix. We will see what is the relationship between confidence level and type 1 and type 2 error. Okay, and suppose some pharma company going to conduct a clinical trial to test the effectiveness of the drug. uh, Suppose if they are conducting, if they are setting a 95 percentage confidence level for the sample size calculation, then if we can conclude the drug is effective, there is a 5%, and then they found the drug is effective. Okay. For example, in clinical trial, what they will do is they will compare their drug with the comparative drug, or they will compare their drug with the placebo. So, and in their clinical trial, if they are concluding the drug is effective, or if the drug is superior to another drug, if the drug is superior to placebo, then there is a 5 percentage of chance we are wrong. Suppose if we are selecting a 95 percentage confidence level for the sample size calculation, there is a 5 percentage chance for the error. Okay. Suppose if we are choosing 99 percentage confidence level for sample size calculation, there is a 1 percentage chance of error. There is a 1 percentage of type 1 error. Okay. So based on the confidence level, there will be a type 1 error involved in the clinical trial. Okay. So and if we conclude the drug is not effective, there is a 5 percentage chance we are also wrong. Okay. So we will see what is the impact of the percentage of confidence level in the sample size calculation. Okay, in upcoming slide, what is the optimal confidence level we have to choose for the sample size calculation? Okay, because we always try to optimize the type 1 error in the clinical trial. Always when pharma company conduct a clinical trial, what they want to do is they want to minimize the type 1 error. Okay, and then they want to minimize the type 2 error also. Okay. Now we will see what is one sample t-test. So I will explain this one sample t-test is also important to understand the sample size calculation. So this one sample t-test comes under the hypothesis testing. Okay. For example, in a observational study, for example, you are conducting an observational study, it helps to identify the prevalence of the diabetes mellitus. Uh, for example, if you want, before going and collecting the study, in hypothesis testing, what we will do is we will form a null hypothesis and alternative hypothesis, and then we will go and collect the data, right? If you don't know the hypothesis testing, then it is fine. I will explain from the scratch. So in hypothesis testing, what we will do is first we will not collect the data and we will not perform the analysis. First we will develop the null hypothesis, alternative hypothesis, and then we will collect the data and then we will calculate the p-value. So based on the p-value, we will accept or reject we will make an inference. We will accept or reject the null hypothesis. So for example, now we are going to conduct a study on the prevalence of diabetes mellitus. First, what you will do is you will form a null hypothesis. Okay, and then you will form an alternative hypothesis. One sample t-test, what it will do is it will tell if the current prevalence of the diabetes mellitus is significantly different from the what was observed historically. For example, in 2024, you want to calculate the prevalence of diabetes mellitus. Uh, and in 2023, already the prevalence of diabetes mellitus was calculated. And in one of the publication, it is mentioned as diabetes mellitus prevalence is 67%. Now, what we have to see is if the current prevalence of diabetes mellitus is significantly different from what was observed historically. Maybe historically means 2023 prevalence of diabetes mellitus. Okay. Now we will see how one sample t-test uh, helps to identify whether the current prevalence is different from the past prevalence. Okay. So if you want to perform a one sample t-test, what you have to do is you have to form a null hypothesis, make a null hypothesis that prevalence of the diabetes mellitus in 2024 is 20%. Okay, so that means compared to previous year, there is no difference. Compared to 2024, there is no difference between the prevalence of the diabetes mellitus. Alternative hypothesis, what we are saying is the prevalence of the diabetes mellitus in the current year is different from 20%. So what we are saying is in 2023, the diabetes mellitus prevalence is 20%. In null hypothesis, we are saying the prevalence is same for 2023 and 2024. But in alternative hypothesis, we are saying prevalence of diabetes mellitus is different between 2023 and 2024. So this is our hypothesis. And then what we will do is, then we will make a significance level. Significance level is what is the percentage of type 1 error. So we are fixing the type 1 error as 0.05%. That means if you are fixing type 1 error as 0.05%, our confidence level will be 95%. If our type 1 error is 0.01, then our confidence level will be 99%. Okay, then what we have to do is gather a random sample from the current population, go to the okay, then you have to collect a survey, you have to do a survey and then collect the data about the diabetes mellitus, and then calculate the proportion of the diabetes mellitus, and then using a t-test, you can calculate the p-value. Based on the p-value, we can make a inference. Now we have set the significance level type 1 error as 0.05, right? Suppose if our p-value is lesser than 0.05, then we will reject a null hypothesis. That means if our p-value is lesser than 0.05, that means our prevalence of 2024 is different from prevalence of 2023. So this is how we will perform the one sample t-test for the prevalence study or for observational study. Now we will see two sample independent test. Okay, so this is two sample independent t-test. This is used in the clinical trial. Okay, for example, some company is developing a clinical trial to compare their vaccine with the other sponsor vaccine. Okay, so when the pharma company want to compare the two vaccine, they will use the two sample independent t-test. What they will do is they will compare the mean difference, and then they will calculate the p-value. Then they will what they will do is based on the p-value, they will collect the evidence to accept or reject the null hypothesis. Okay. Now we will see what are all the steps involved in the two sample independent t-test. Uh, okay. Now, for example, Pfizer recently they developed the COVID vaccine, right? Uh, if Pfizer is developing a null hypothesis, what they will do is they will write a null hypothesis saying that there is a no difference in outcome between the COVID vaccine and the placebo. Okay. An alternative hypothesis will be there is a significant difference in outcomes between the COVID vaccine and placebo. So in null hypothesis, we will say there is no the vaccine effectiveness. There is no difference in outcomes between the vaccine and placebo. In alternative hypothesis, we will say there is a statistical significant difference in outcome between the COVID vaccine and the placebo group. Okay, so this is how the pharma company make the null hypothesis and alternative hypothesis. And then they will select the type 1 error or the significant level. If they are selecting a type 1 error as 0.05, confidence level will be 95%. If they select a significance level or type 1 error as 0.01, then our confidence level will be 99%. Okay, then what they will do is they will collect the data, they will conduct a clinical trial, then they give the vaccine to the subject. Also, they give the placebo to the participants, and then they will calculate the antibody concentration. Once they calculate the antibody concentration, they will calculate the mean for both vaccine and placebo group. And then what they will do is they will use the t-test to calculate the p-value. Based on the p-value, we will make an inference. Suppose our p-value is lesser than type 1 error, then what we will do is we will make an inference that there is a significant difference in outcome between the COVID vaccine and placebo. Okay. So this is how the pharma company will develop the null hypothesis and alternative hypothesis, and then they will perform a two sample independent t-test. Okay. Okay, so these are all the basic concept you should know to understand the sample size calculation. Once again, I will come from beginning. Okay, so first we have seen what is sample size, and then we have seen what is the impact of small sample size and what is the impact of large sample size. And then we have seen disadvantage of large sample size. One is cost and time, and then is an increased chance of false positive. And then uh, what is the goal of optimal sample size? How we can reach the optimal sample size? And then we have seen a basic concept for sample size calculation requirement, confusion matrix, and then we have seen true negative, true positive, and then type 1 error, type 2 error. And then we have seen accuracy, the how many times X-ray correctly predicted the fracture, precision, how many time X-ray predicted fracture correctly among the total number of predicted fractures. And then we have seen what is type 1 error, type 2 error. And then we have seen what is the confidence level. Suppose if we are selecting 95% confidence level for sample size calculation, then in your future estimate like prevalence or mean difference, there is a 95% chance that your statistics will be accurate. And then we have seen what is the relationship between confidence level and type 1 and type 2 error. Suppose if we set the 95% confidence level, then there is a 5% chance of error in our estimate. Suppose if you are choosing 99% confidence error, there will be a 1% chance of type 1 error. Suppose if your drug is not effective, there is a 5% chance of type 2 error if the drug is not effective. Okay. So you should understand type 1 error is false positive, type 2 error is false negative. Okay. So what this pharma company will do is they will try to minimize the type 1 error and type 2 error in while calculating the vaccine efficacy or drug efficacy. Whenever they are calculating the vaccine efficacy or drug efficacy, what they will do is they will try to minimize this type 1 error, and then they will try to minimize the type 2 error. How they will achieve? They will use the sample size calculation. There they will give the confidence level and type 2 error. By using the sample size calculation, they will minimize the type 1 error and type 2 error. Okay. Then we have seen one sample t-test. Okay, so one sample t-test, we have seen the example of prevalence of diabetes mellitus. So in null hypothesis, we are saying prevalence, there is no difference between prevalence of 2023 and prevalence of 2024. Alternative hypothesis, we are saying there is a difference between prevalence of 2024 and prevalence of 2023. Then you have to decide a type 1 error significance level. If you are keeping 0.05 as a significance level, then your confidence level will be 95%. And then collect the data about the prevalence of diabetes mellitus for 2024. And then use a t-test to calculate a p-value. Once you calculate the p-value, you can collect the evidence to reject or accept the null hypothesis, okay, based on the p-value. And for two sample independent test, two sample means you will have two group like vaccine versus placebo or the vaccine versus comparative vaccine. You will have two independent groups. Whenever you have two independent group, then only you can use a two sample independent test. Okay. So when we have seen a clinical trial example, we have seen an example of COVID vaccine. So when Pfizer, 2021, Pfizer developed a COVID vaccine, right? At the time, how they formed a null hypothesis is they will form a null hypothesis saying that there is no difference in outcome between the COVID vaccine and the placebo group. An alternative hypothesis, they will say there is a significant difference in outcome between the COVID vaccine and placebo group, and then they will set a significance level, type 1 error, and then they will collect the data, they will conduct a clinical trial, and then they will collect the antibody concentration. They will collect the antibody concentration for COVID vaccine group and placebo group. And then what they will do is they will calculate the mean difference between two group, and then they will calculate the p-value. Based on the p-value, they will either accept the null, they will collect the evidence to accept or reject the null hypothesis. Okay. So one thing you have to one thing you have to remember is based on the significance level, your type 1 error and type 2 error will be optimized. Okay. How we will set the significance level is during the sample size calculation, we will give the input of type 1 error, type 2 error, and then we will also give the some other parameters. So in upcoming slide, we will see what are all the factors which will impact the sample size calculation. So until this, if you have any doubt, you can put your question in a chat box. I will wait for a minute. If you have a question, you can put your message in a chat. I will wait for 1 minute. Otherwise, I will go to the next slide. Okay. Okay. Priya Singh. Okay. Priya, you are asking which t-test, right? What is your objective? You want to calculate the prevalence, or you want, what is your objective? You want to calculate the prevalence of what? What is your objective of your study? Okay. For example, you should use the one sample t-test. Okay. It is called one sample t-test. Okay. You can go through the one sample t-test, but if you are having two group or like an interventional study, you should use two sample t-test. Okay. And also, you should remember when you are going for a one sample t-test, you should select the sample size. So based on the sample size, it will differ. Suppose if your sample size is lesser than 30, go for a one sample t-test. Suppose if your sample is greater than 30, then go for one sample Z test. Okay. So it is also based on the sample size also. Okay. Based on the sample size, you will go for either T test or Z test. Okay. Okay. Shraddha is asking type 1 error. Okay. So maybe I will go to the confusion matrix. Okay. If you see this confusion matrix, uh, type 1 error, what it means is X-ray is predicting the, for 10 subject, X-ray is predicting as fracture, but in actual report, all of 10 doesn't have the fracture. Okay. So type 1 is something that your statistical value predict the 10% as the fracture, but in reality, all the 10 participant doesn't have the fracture. Okay. And in same example, for example, 55, okay, okay. 5 are not pregnant, okay, but as per the actual report, they are pregnant, okay. So type 1 error is nothing but your statistics method is saying that the 10 participant having the fracture, but actual report is saying that 10 participant doesn't have the fracture. Okay. So that means your statistical method is showing some error. Okay. So we are saying how many percentage of participant have this type 1 error we are going to see. Okay. I will again repeat. As your statistical method is saying that 10 participant have the fracture as per the X-ray report, but as per the actual report, all this 10 participant doesn't have the fracture. Okay, it means your statistical method is saying 10 having fracture, but in reality, the 10 doesn't have the fracture. So there is some error. That error is called type 1 error. Okay. So in reality, there is a fracture, but is your statistical method wrongly predicted they are having a fracture. Okay. So that is called type 1 error. So in general, in our example also, if you see two sample independent test, suppose for example, in our two sample t tests say that there is no difference in outcome between the COVID vaccine and control group, but there is a 5% chance that it wrongly predicted the difference. Okay. So when you are choosing a significance level, you are setting the type 1 error. Okay. Because why we are setting a type 1 error is we are calculating the data from sample, right? We are not calculating the data from entire population. So we are setting the significance level type 1 error. So we are saying there is a 5% chance that 5% chance that t-test wrongly predict the outcome. Okay. So again, I will repeat, type 1 error is nothing but how your statistical method wrongly predicted the positive value. Type 2 means how your statistical method predicted the wrong negative values. Okay. So this is what type 1 and type 2 error means. Okay. Okay. Bhavna, you are asking on what basis confidence interval is set in yeah, sure. I will tell in upcoming slide. Okay. Okay, so GS is asking if I want to calculate and safety and effectiveness, which test I have to use. For example, Pfizer is 2021, they developed a COVID vaccine, right? When they are developing a COVID vaccine, for safety, what they will do is they want to maintain a safety profile same as COVID vaccine and placebo. For both placebo and safety vaccine, the safety profile should be same, right? The adverse event should not be more in COVID vaccine group compared to placebo, right? So for safety test, what they will do is they will set a null hypothesis. They will use the same independent t-test. Okay. And then they will say there is no difference in adverse event between COVID vaccine and placebo group. Okay, this is for safety parameter. What they will do is they will say there is no difference in adverse event between the COVID vaccine and placebo group. In alternative hypothesis, what they will say, there is a significant difference in adverse events between the COVID vaccine and control group. Okay, what they will try to do is they will try to accept the null hypothesis. Okay, because the safety profile should be same between the uh, COVID vaccine and placebo group. But coming to the efficacy, what they will try to do is they will try to prove there is a significant difference in vaccine effectiveness between COVID and placebo group. Okay, so depends on safety, they will try to match the null hypothesis. For effectiveness, they will try to reject the null hypothesis. Okay, but for both safety and effectiveness, they will use the two sample independent t-test. Okay, only the null hypothesis and alternative hypothesis differs. Okay. 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 So, Shugana, you are saying my study use involves of some scale for classifying OCD severity. So for this, I need more input for you from you. Maybe I will contact you offline. I will give my mail ID here. You can just provide me more detail about your project. Okay. Then I will come back to you with the answer. Just tell me what is your questionnaires and what is the score, what is the minimum value, maximum value. Give some more information about the data. Then and what is your objective. Then I will come back you with the answer. Okay, I have given you the mail ID. Okay. Okay, Bhavna, okay. On what basis the confidence interval is set? In upcoming slide, we will see. Okay, okay. So now what we will do is we will in this session we will try to calculate the sample size for two different study. One is observational study, another is interventional study. Observational study means there will not be any intervention involved. Okay, like cross-sectional case control study. The main most of the observational study they will try to calculate the prevalence of the disease. In interventional study like clinical trial, what they will do is they will try to test the drug effectiveness or vaccine effectiveness. Okay. So we will see the sample size calculation for both observational study and interventional study. So we will see what are all the factors affecting sample size for observational study. Okay. The one is precision. We have seen in confusion matrix precision, right? Precision is nothing but the number of correctly predicted SS to the total number of predicted SS. That means how many times X-ray predicted fracture correctly divided by total number of fracture predicted fracture predicted no X-ray predicted fractures. Okay, so again I will repeat. The precision is nothing but how many time X-ray predicted fractures correctly divided by total number of times X-ray predicted fractures. Okay, so this is about the precision. I will again repeat it. Precision is nothing but how many time X-ray predicted fracture correctly among the total number of X-ray predicted fractures. But if you see accuracy, the denominator include all the participants, but in precision, the denominator will be only the total number of predicted S's. Okay, so that the precision is different from accuracy. Now we will see how the precision will impact the sample size. Okay. The precision is nothing but the amount of degree of accuracy detail you want to achieve in your esteemed result. Esteemed result is nothing but consider like you are going to conduct a study on prevalence of diabetes mellitus. So the precision is nothing but degree of accuracy detail you want to achieve in your esteemed result. Esteemed result is nothing but the what you are going to calculate, like prevalence of diabetes or prevalence of tuberculosis. Okay. High precision means narrow confidence interval. Okay. Around your esteemed prevalence. Okay. It is like pinpointing a specific location. Okay. Maybe I will give you an example. I hope you may know about the confidence interval. Okay. So before going, if you want to understand this line, you should know about the confidence interval. Confidence interval is nothing but it is the range of value which make inference about the population. Okay. For example, population is not okay. So, for example, in prevalence of diabetes, so you are conducting some observational study, and then you are measuring the prevalence of diabetes for 2024. Okay. Then before going to the study, you are setting the confidence level is 95%, and then you are calculating the percentage, prevalence or percentage value. So what we will do is we will calculate the confidence interval for percentage. So instead of mentioning a single value, we will make a range of value. So for suppose you are getting 67%, then your confidence interval will be something like 63% to 70 percentage. Okay. So instead of mentioning the single value, we will present the confidence interval by multiple values. Okay. So this is called lower limit and this is called upper limit. Okay. So for here, the prevalence is 67%. The lower limit of confidence interval is 63 and the upper limit is 70 percentage. That means we are saying that the our prevalence of diabetes mellitus lies between 63 percentage to 70 percentage. So again, I will repeat, we are 95 percentage confidence that the prevalence of diabetes mellitus lies between 63 percentage to 70 percentage. Okay. Suppose if you are making a confidence level 99 percentage, then your prevalence will be, so if you are taking 99 percentage confidence level, then your confidence interval value will be, we are 95 percentage confidence that the prevalence of diabetes mellitus lies between 66 to 68 percentage. Okay. So when you are selecting a confidence level, bigger confidence level, your margin of error will be very small. Okay. So here, see, the margin of error is only the interval size is only 2. But if you see, if you take confidence level 95 percentage, if you are keeping type 1 error 5 percentage, then the margin of error is very huge. The interval size is very huge. Okay. So when you are making an inference about population, there is the interval of 7. But when you are having a confidence level 99 percentage, the interval range only is 2. Okay. So when you are having a bigger confidence, the margin of error also comes down. The inference will be more accurate. Okay. So when you are saying higher precision means it will narrow the confidence interval. Okay. So that means when you are selecting 99 percentage confidence, the confidence interval will be very narrow. So uh, the inference will be more accurate. Okay. Okay, so this is called precision. We will see what is the precision we have to select for the sample size calculation. Okay. Uh, Suppose if you are calculating a higher precision, then your sample size will be more. For example, if you are choosing 95 percentage precision, then your sample size will be 500. Suppose if you are selecting precision as 99 percentage, you want more accurate result, then your sample size will be like 1000. Okay. So based on the precision level, your sample size also may be differ. Okay. But based on the precision, you can optimize the type 1 error also. Okay. Then the second important, the first parameter impact the sample size's precision. The second factor which impact the sample size is expected prevalence. Okay. Expected prevalence is your best guess. Okay. Based on your existing knowledge or preliminary data, how common a particular characteristics or condition is within the population you are studying. Okay, it is like aiming your flashlighting in the right direction to find what you are looking for. So when you are calculating a sample size, you should give one input called expected prevalence. Okay, so that is in 2024, what is your expected prevalence of diabetes mellitus? Okay, so how we can guess the expected prevalence, I will explain it in a previous upcoming slide. Okay. For example, if you are estimating the prevalence of rare disease, something like HIV, suppose if you are estimating the prevalence of rare disease like HIV that affects the 1% of population, then you would require a large sample size. Okay. Uh, but if you are estimating the prevalence of obesity, this is very common problem, right? Then for obesity, you may require a small sample size. Okay. So higher expected prevalence, like prevalence of obesity, you may need a small sample size as you are more likely to encounter individual with the same characteristics within a smaller group. Okay. So when you are having a higher expected prevalence, the you will have the individual with the same characteristics. But when you have a rare disease, the variance will be very high. Then your sample, you may need a larger population. But when you have a common disease, you may need a smaller population. Okay, so based on the type of disease also, the sample size may go up or down. Okay, so it is based on the frequency of disease occurrence also. Okay, so for you, I as I told you, you have to give the one of the sample size calculation. You have to give the expected prevalence, right? So what is the source for expected prevalence? Articles and see what is the prevalence of diabetes mellitus in 2023, and then you can give us a input to the sample size calculation, or you can conduct a pilot survey. You can conduct a pilot study. Okay, 1 minute. Okay. Otherwise, what you can do is about the prevalence of diabetes mellitus, and then you can calculate the percentage and you can give it as an input to the sample size calculation. Or you can ask a expert opinion. You can go to the doctors who work on diabetes mellitus, or you can go to the researchers who work on diabetes mellitus and consult with the expert. And then based on their knowledge, you can give us the input to the sample size calculation. Okay, or utilize the public health disease surveillance data available in the website. Okay, so based on this, you can take the input for sample size calculation. So expected prevalence is nothing but what is the prevalence of diabetes mellitus, what is the prevalence of your disease of interest. Okay, expected prevalence. So this is also one of the input for the sample size calculation. And also one more thing, based on the occurrence of disease, the sample size may go high or down. If it is rare disease, then we need a larger sample. Like prevalence of HIV, you may need a prevalence of larger sample. But if it is prevalence of obesity, prevalence of cough, then you need a very a small sample size. Okay. So what if I am in your suppose if I am conducting if I am conducting a observational study for expected prevalence, what I would do is first I will do a pilot study, or I will use the previous journals, and also I will ask a expert opinion, and then I will give the input to the sample size calculation. Okay. Then the confidence level, as I explained, confidence level. Uh, uh, what is the uh, what is the percentage you are confident that your results are accurate? Okay. So in observational study, you will measure the prevalence of diabetes mellitus, right? So how accurate your results will be, your future results will be. Okay. Suppose if you are choosing higher level of confidence level, 99 percentage if you are choosing, then you may need a more number of subjects. It may be very costly and it may be time consuming. But if you are choosing a lower level like 80 percentage, 85 percentage, then your sample size will be lower. It will be a higher chance of type 1 error. Okay. So you have to find a optimized confidence level. So what we have to do is one of the medical research, if you are estimating the prevalence of diabetes in a community, if you are selecting 95 percentage confidence level, you may require 400 individuals to survey. But if you are selecting 99 percentage confidence, you may need 600 individuals. Okay, so you need more than 200 individuals. Okay, but when you are selecting 95 percentage confidence, there will be a 5 percentage of type 1 error. But if you are selecting 99 percentage confidence level, there will be only 1 percentage of type 1 error. Okay. So, so what you have to do is you have to find the optimize. So you have to find the confidence level. Then you have to see whether you will be able to survey 600. Okay, if you are able to survey 600, you have a money, you have a cost, you have a time, then you can go for a 600. But if you don't have a time, if you don't have the cost, then reduce your confidence level and go for the risk of type 1 error. Okay, so it is all based on the your decision, based on the cost, based on the time, and based on the money. You can select the confidence level. Okay. And then another important factor is data variability or standard deviation. Okay. Okay. So I will explain what is this data variability means. For example, in observational study, what we will do, generally we will calculate the prevalence of disease, right? The data variability refers to the natural difference or spread in the characteristics. For example, you are going to survey 400 people for diabetes mellitus. If you take 400, so many people may be younger, so some people may be older, some people may be obese, some people may not be obese, some people cholesterol level may be high, some people cholesterol level may be very different. So when you are so whenever there is a huge spread in the data, that also impact the sample size calculation. Okay. So we will see what is the data variability. Data variability is nothing but spreadness in your data. Okay. Spreadness in the various characteristics like age, gender, and cholesterol, BMI, different co-founders. Okay. Suppose if you have if you for large sample size, we will see. Suppose if you are estimating the prevalence of hypertension, community with the diverse lifestyle and risk factors would require a large sample size. Okay. So if you are going to conduct a study for measuring the prevalence of hypertension, with the diverse lifestyle and risk factors, obviously the spreadness will be huge. Everyone may be different, their lifestyle will be different, some people will their food style will be different. Okay, the risk factors will be different. So obviously the spreadness will be huge. When the spreadness is huge, we need a large sample size. Okay, but when you are going to conduct a study on the prevalence of genetic condition with a specific set of diagnostic character, then you will have the population with the same set of characteristics. Okay, so when the spreadness is very less, when the standard deviation is less, then you may need a very small sample size. Okay, so when the data variability is huge, then you may need a large sample size. But if the data variability standard deviation is very small, then you may need a very small sample size for the study. Okay. So based on these factors only, we will select the data variability. So what is the source for data variability? You can go to the past journals and you can see the past journals regarding the prevalence of hypertension or prevalence of genetic condition, and search for a similar article and see what is the standard deviation they have used for sample size calculation, or conduct a pilot study, then conduct a pilot study on prevalence of hypertension, and then calculate the standard deviation, and then use the standard deviation for sample size calculation. Okay, and then expert opinion also. Suppose if you are calculating the genetic disorder hypertension, then you can go to the researcher who are working on the particular area. Based on their opinion, you can select the values for the data variability. Okay, so the four input for the sample size calculation is: one is precision, and expected prevalence, and confidence level, and then data variability. So these are all the four inputs you will give for the sample size calculation for observational study. Okay, we will see this example in G power also. So whenever you are calculating a sample size for observational study, you have to give the input for precision, you have to give the input for expected prevalence, you have to give input for confidence level, and you have to give input for the data variability. These are all the factors affecting the sample study. Okay, so okay, let's see what is the formula for the sample size for observational study, for prevalence study. So this is the formula: N is sample size, Z is the statistics for the level of confidence. So if you are selecting 95% confidence, the Z value will differ. If you are selecting 99% level of confidence, Z value differs. Okay. So if you are giving higher level of confidence, the sample sizes will also increase. So your Z is in numerator, right? So if you are giving more level of confidence, then your sample size also increase. So N is directly proportional to the Z value, and then expected prevalence. Okay, P is nothing but the expected prevalence, and then D is the precision. Okay, okay. So P into 1 minus P is the standard deviation. Okay. So if you are having a binomial distribution, you can go and search in internet. P into 1 minus P is the standard deviation. Okay. In formula, you will not directly find the standard deviation. So standard deviation is nothing but P into 1 minus P. That is standard deviation. Okay. For binomial distribution, you can search it in internet. The standard deviation is nothing but P into 1 minus P. So for sample size calculation, what you have to do is you have to give input only for P value, Z value, and precision. Now what we will do is we will go to G power, and then we will calculate the sample size calculation. Okay. So first I will tell G power is the free software. What you can do is you can go to this website and you can download the software from the front page. So if it is window, download this link. If you are using Mac OS, then download this link. So I will give the link of this website. When you have a free time, download this software. Then only you will be able to do a sample size calculation. So when you have a free time, please go and download the G Power software from this website. Okay. So now what we have to do is, if you are going to calculate the sample size calculation for observational study, for observational study, you will have only one sample. Okay. And also we have seen some one sample t-test, right? When you are going to for a sample size calculation, you should select the one sample t-test. Okay. So I will tell what you have to do is, so select the test as exact, and then select for what you have to do is in test family, select exact, and then what you have to do is, what we are going to calculate for observational study, we are going to calculate the prevalence, right? Prevalence is nothing but proportion, and then take one sample case, and it is a binomial distribution. So the statistical test will be proportion difference from consent, a binomial test, one sample. Okay. And then type of power analysis, what you have to do is select the priori option. So here you will have alpha, power, and effect size. Okay. So I will tell what this input means. Okay. Okay. First, we will see the alpha. Alpha is nothing but the confidence level. Okay. Alpha is for example, if your confidence level is 95, then your alpha will be 1 minus 95, that is 5%, that is 0.05. Okay. So based on the confidence level, your alpha value differs. Okay. Suppose if your confidence level is 99, your alpha will be 1 minus 99, that is 1%, that is 0.01. Okay. So based on the confidence level, your alpha value will differ. So instead of giving alpha value, confidence level, we will give alpha value. Okay. Significance value. That is type 1 error. Okay. So we are selecting 0.05. That means we are selecting 95% confidence level. Constant proportion, what is the expected prevalence? For example, we are going to calculate the prevalence of diabetes mellitus in 2024. So what we did is we went to previous journal and we found in 2023 the prevalence of diabetes mellitus is 0.023. Okay. So this is taken from the previous article, and effect size is nothing but, okay. Suppose if we are giving 0.4 or 0.2, that means what you are doing is you are creating a margin of error 0.2. Okay. That means 20%. Your margin of error will be 20%. Okay. So for example, your proportion is 0.02, right? So what we have to do is, if you are having margin of error, so plus 20%, minus 20%. Okay, so your results lies within the two range of values. Okay, margin of error means the error which can be expected in your result. So it will be plus or minus 20%. Whatever prevalence value you are getting, there will be plus or minus 20%. Okay. So this is something related to standard deviation. How much spreadness, how much deviation from your result. Okay. And power, now we will keep 95 percentage. By default, you keep 80 percentage. In upcoming slide, I will explain what is power. For interventional study, we will keep we will use mainly power. For observational study, just simply keep 80 percentage. And then now click calculate. Okay. So now, for example, if your prevalence is 0.023 and then your total sample size is 13. Okay. But if you increase the confidence level, I want 99 percentage confidence level. Then let's see what is the sample size. See, when I select 95 percentage confidence, sample size is just 13. But if I need more confidence on my result, I want less error, then the sample size also increases. Okay. Same thing, suppose if you increase the proportion, if your prevalence is 0.6, okay, then the sample size also increases. Suppose if I keep 0.4, see, it is 63. If I keep 0.5, it is 64. If it is 0.7, it is 0.44. Okay. So if it is more frequent, prevalence, then the sample size will be lesser. But if it is not very frequent disease, then the sample size may be more. Okay. So based on the proportion value, based on the alpha value, based on the effect size, your sample size may differ. Okay. So if you have a cost, if you have a time, if you have the power, if you have the money, then you can go for a higher sample. You can increase the confidence level. If you have a lesser money, then you can adjust the alpha rate. You can go for little risk of type 1 error, and then you can take a survey only for 37 subjects. Okay. So this is how you will calculate the sample size in G power. I will again explain. In test family, go to exact, and then in statistical test, select proportion. Since we are calculating prevalence, right? Prevalence is nothing but percentage of proportion. And then select the difference from constant, and then type of power analysis, select priori sample size given alpha, power, and effect size. Okay, first alpha, the level of confidence or the type 1 error, and then expected proportion, and then effect size, how much deviation from margin of error you want to keep, and then power. Now just default keep 80 percentage. For observational study, power is not required, but just for a demo purpose, I'm keeping 80 percentage. So by tweaking effect size, by tweaking error, but proportion will be constant value. Okay. uh okay. Effect size come from the previous study. Okay, it's a good question. um Okay. I will tell expected size is something like difference. Okay, I will go to notepad and explain. So expected size will be something like prevalence of 2024 minus prevalence of 2023. Okay. So something like margin of error. Initially, what we are for expected proportion, what we do is we will take the prevalence of 2023 and then we will give the value as zero point 0.5. Okay. We will give the expected proportion as 0.5. Okay. And then effect size is something like prevalence of 2023, 2024 minus prevalence of 23, something like a margin of error. For example, if you are assuming prevalence of 2024 is also same like prevalence of 2023, then it will be zero, right? Effect size. But since we are calculating our data from sample, there will be some always margin of error. So what you have to do is select the some margin of error and then you give the input. Okay. So this is also based on the you can ask the expert opinion. What is the effect size we can expect from 2024. So what that expert will do is they will see the trend of 2021, 2022, 2023, and 2024, and then they will provide you the effect size value. Okay. So based on the expert opinion, you can select the effect size. Okay. Or you can you do this is not like publication or anything. So whatever you can do is, or you can do another thing also. If you don't have the expert opinion, conduct a small survey and then calculate the prevalence of 2024 and then calculate the effect size. Okay. Or if you don't want to conduct a small survey, then ask a expert opinion. Okay. So, okay. So it doesn't come from the previous study. We can ask a expert opinion, or you can conduct a survey with a smaller population. Priya, you understood, or you want me to explain once again? Okay. Okay, perfect. If there is any other question, so okay. So under effect size, you can go with the expert opinion, or you can conduct a sample survey. Proportion, expected proportion, you can take it from older study or older journals, or you can conduct some small. You can conduct some sample study. Alpha, what is the percentage of type 1 error? Okay. If you are giving 0.05, you will get a less sample size. If you are giving 0.01, you will get more sample size. Okay. Okay. Pilot study means, for example, now you want to conduct a diabetes mellitus, right? Prevalence of diabetes mellitus. Pilot study means go to Apollo hospital, go to any hospital, and then collect a survey there and collect the data from hospital and see how much the prevalence is. And you can collect the data from hospitals, you can collect the data from health records. Okay. So conduct small study and see what is the prevalence, or take a survey and see what is the prevalence of 2024. Okay. So pilot study means you will conduct some survey or you will collect some data for a smaller amount of subject, for like 5 to 10 subject. You will see. So maybe you will conduct a pilot study on 10 subject. you will go to hospital and you will check the diabetes mellitus for 10 subject. You are finding the expected prevalence as out of 10 subject, 3 subject as diabetes mellitus, and then the prevalence is 0.3. Okay. So like that, you may go to hospital, you may go to some data collecting center, and then you will see what is the prevalence. So we found out of 10 subject, 3 subject as the diabetes. So the expected prevalence will be 0.3. Praveen, you understood? Okay, perfect. Okay. Then as I said, what two things you can control. So based on the effect size, you can control the sample size. Okay. So if you select the confidence level, 95 percentage confidence, 37 sample size. But if you want more confidence, if you want 99 percentage confidence of the result, then your sample size will go higher. Okay. If you have a time, if you have a cost, you can go for the higher sample size. Otherwise, you just optimize the alpha value like 0.003, 0.004. Optimize the type 1 error. Yeah. Okay. Any other questions? Otherwise, I will go to next topic. Okay. Okay. Now we will see the sample size calculation for interventional study. Okay. So in interventional study also similar to observational study, but one thing different is in observational study they have the precision, right? Here we will have the power. Okay. So power and precision is somehow similar only, but in upcoming slide, we will see what is precision. We will go one by one input. So for interventional study, you need to give 4 input for sample size. First is expected out effect size. Second is data variability, standard deviation. Third is significance level or confidence level. Fourth is power. Okay. First, we will see what is expected effect size. Okay. Uh, First, for example, in clinical research or in clinical trial, the effect size is nothing but the magnitude of the difference between two groups. For example, if Pfizer is conducting a clinical trial, they want to compare their Pfizer vaccine with AstraZeneca COVID vaccine. What they will do is they will first, before starting the trial, they will find the expected effect size between Pfizer COVID vaccine versus AstraZeneca COVID vaccine. So they will try to find the magnitude of difference between two vaccines. Okay. Suppose if the expected difference, if the difference is huge, then we need a small sample size. But if the difference is small, then we need a larger sample size. Okay. For example, if the vaccine effectiveness is difference is huge between AstraZeneca and Pfizer, then we need a small samples. But if the vaccine effectiveness is high between AstraZeneca and Pfizer, then we need a larger sample to see them clearly. So, okay, I will explain. Okay, so if you see observational study, what we will do is we will see the prevalence of 2024 minus prevalence of 2023, right? In interventional study, in clinical trial, what we will do is we will see effectiveness of Pfizer vaccine minus effectiveness of AstraZeneca vaccine. Okay, so it is the effectiveness between two vaccine, effectiveness between the two group. So that is called effect size. Okay. So if the difference is huge, then we need a small sample. If the difference is tiny, then we need a large sample size. Okay. Generally, if Pfizer is conducting a clinical trial, what they will do is the difference will be smaller because both AstraZeneca, Pfizer vaccine works well against COVID. So the effectiveness may be very tiny. So they may need a larger samples to see them clearly the difference. Okay. For example, for in COVID vaccine trial, uh, for example, the Pfizer is conducting a clinical trial. Their COVID vaccine produces the mean antibody level of 500 units, and placebo group as the mean antibody. So once the vaccine is given, they will measure the antibody level, right? So once the COVID vaccine is given, your body will produce the antibody against COVID antigen, right? So so what in clinical trial, what in pharma company, what they do is once the vaccine is given, they will measure the antibody level. So they are measuring the antibody level for both COVID group and placebo group. Effect size is nothing but mean difference. So in this case, effect size will be in COVID vaccine 500 minus 100. Okay. So it is 400. The effect size is very huge. So in this case, the sample size is we need a very small sample size. Okay. But if you are going for a flu vaccine trial, yeah, for in suppose GSK having a flu vaccine, right? GSK vaccine produced the antibody level of 350 level, and placebo, or consider this as another sponsor, maybe Pfizer. Pfizer also has the flu vaccine. Pfizer flu vaccine has the antibody level of 350. Placebo, for placebo group, antibody level is 250. So here the effect sizes 250, it is 100, right? So if you see the COVID trial, the effect size is huge. So they need a small sample to see the difference between the two groups. But the effect size is small. You need a large sample size, okay, to see the difference. Okay. So this is the example for effect size. Okay, so this is the parameter for the first parameter for the sample size calculation in interventional study or in clinical trial. Okay, the second is data variability, standard deviation. Okay, for example, some pharma company, they are working on the drug for the odd rate. Okay, so for example, in group A, everyone odd rate is very similar, like 60 to 70 beats, smaller sample for group A. So for example, if everyone out is very similar, rate is similar, then we need a smaller sample size. But in group B, if the odd rate is very widely, if the rate is ranges between 40 to 100, then the spreadness is heavy. Then we need a larger sample size to see the difference. Okay. So based on the data variability, we need the sample size. Okay. If the data variability is small, if the data variability is small, then we need a small sample size. If the data variability is huge, like 40 to 100, the spreadness is 60 here, right? If the spreadness is huge, then we need a larger sample size. Okay. So this is also you can find the data variability from the previous journals or studies. For example, if you want to if you want to do some research on the flu vaccine, there are so many studies in ct.gov website or so many journals available on the flu vaccine, right? So you can go to old studies of flu vaccine and you can see what is the standard deviation they used for the data variability used in the sample size calculation. So this is the okay. Okay. So this is the second input for the sample size calculation for the interventional study. The third one will be the confidence level. Okay, so we have seen already the confidence level. Confidence level is how confidence you are the true value of the population parameter, how accurate your results are. Okay, so based on the confidence level, your error type 1 error will be decided. If you choose the higher level of confidence level, then you may need a higher sample size. Higher sample size may lead to costly and time consuming. Lower level of confidence level or faster and cheaper, but there is a high risk of type 1 error. Okay, so based on your requirement, you have to choose the confidence level. So as I explained, 99% confidence level may lead to higher sample size. 95 percentage level may be smaller compared to 99 percentage confidence level. Okay, so based on the confidence level, the sample size go up or down. So based on your requirement, you can choose your confidence level. The final one is power. Okay, let me explain what the power. Okay. Power means actually the chance of catching a real effect when it is actually there. For example, uh, I we have seen one example, right? Flu vaccine trial. For example, here the effect size is just 100, right? The effect size is very small here. So in this kind of scenario and all, we need to have a high power. Okay, if you have a less power, then the our statistical method won't identify the difference between the two groups. But if you have a high power, what it will do is, even if there is a minute difference, it will be able to identify the difference between groups. Okay, suppose if your power is very lesser for the clinical trial, if you are selecting a less percentage, if you are selecting 40 percentage power, or if you are selecting 50 percentage power, then it will not, your statistical method will not able to identify there is a difference between the flu group and placebo group. Okay. So power is nothing but the chance of catching a real effect when it is actually there. If you are having high power, then it will increase the sample size. Okay. But if you have a lower power, it will go for the small sample size. It will save time, but there is a increase the risk of missing the real effect. There is the risk of missing the minute difference in the effect size. Okay. So especially when pharma company want to find the minute difference between the two group, then what they will do is they will increase the power and then they will calculate the sample size. Okay. Okay. So for example, when there is a clinical trial for new cancer therapy, the high power more than 80 percentage should be required to confirm a potentially curative treatment. Lower power might be acceptable for a smaller trial, okay, or supportive therapy aimed at symptom management. Okay. So when there is a minute difference, like a flu vaccine trial, minute effect difference, then you need a higher power to find the difference between the two groups. Okay. So these are all the inputs for the sample size calculation for interventional study. Expected effect size, you can, as I told, the effectiveness of vaccine minus effectiveness of placebo. Okay, and then this expected effect size, you can do the pilot study, or you can do the, you can take it from the previous study. Data variability. If your data has small variability, then you need a large. If your data has a big difference, okay, sorry. So okay, if there is a, for example, we have seen data variability, right? If the variability is very small, okay, then you need a small sample size. But if your data has a huge variability, suppose if your measurement is on antibody concentration, right? For all the subject, if the antibody concentration is similar, then you need a small sample size. But if all the for all the subject, if the antibody concentration range is very wider, then you need a larger sample size. Okay, so this samples, so based on the spreadness data, based on the standard deviation data, your sample size may increase or decrease. Okay, based on the standard deviation of your data. Confidence level. So it tells how much your results are, how much your result accurate is. Okay. And also it decides the type 1 error also. Highest level, if you are deciding 99% confidence interval, it leads to high sample size, but it is costly and time consuming. Lower level, it is faster and cheaper because it lead to small sample size, but there is a chance of type 1 error. Okay. And then we have seen example of 99% level, 95% level. And then power, we have seen whenever the effects, whenever whenever the effect size is small, then you need a high power to find the difference, minute difference. Okay. Whenever you have a minute difference in effect size, you need a high power. But if the effect size is small, then you can select the lower power. Okay. So this is the sample size formula for interventional study. Sigma is the standard deviation. The denominator as the effect size, that is difference. Okay, and then we have the power on beta, right? Z beta is the power, and Z alpha is the confidence level. Okay, so you see, we have the effect size input, we have the data variability input. Beta is the power, alpha is the confidence level. Okay, so based on this, we will calculate the sample size calculation. Let's see this in a G power. So for when you are when you are calculating a sample size for two independent group, select t-test and then select statistical test, and then we are calculating a difference between two independent means, right? So what you have to do is we are calculating a mean difference between two independent means. That is antibody concentration of Pfizer vaccine minus antibody concentration of AstraZeneca vaccine. Okay. And then we will select the type of power analysis. Power. Okay. So we will have two things. Okay. Okay. Then first we have to give what is the effect size. Okay. The difference in the difference in the two group, two mean, and then what is the alpha and what is the power. Okay. For example, based on the effect size, you can select the power. So now I am selecting the power as 80%, and let's see what is the sample size. So for group 1, we need, for Pfizer vaccine, we need 51 participant. For AstraZeneca vaccine, we need 51 participant. Suppose if we are selecting a power as 70%, not 50%, then the sample size will also go down. See the 23. But if our effect size is, so always see power, we will decide based on the effect size. So I will keep power as 80 default value. and alpha, based on your sample size, you can select the requirement. Okay. So if you have a cost to enroll 82 subjects in group 1, 82 subjects in group 2, then you can go for this alpha level. But if you don't have a cost, then increase the type 1 error and reduce the sample size. Okay. And this effect size is all based on the older study or based on the pilot study. You can select the effect size. Okay. So this is how you have to do the uh, uh, sample size calculation for difference in two groups. Okay. So I will explain. You have to go to t-test and then select the uh, mean difference between two independent means, and then type of power, select priori, compute record sample size given alpha power, and then effect size will be fixed based on your expert opinion or based on the older study, and then alpha you have to adjust based on your cost, based on your time, power based on the effect size you have to choose. Okay, so based on this, you can calculate the sample size. So this is how you will calculate the sample size calculation for two independent group. If you have any questions, put put your message in a chat. Okay, if you have any questions, put your question in a chat. Maybe I will go once again. We have seen two types of sample size calculation. One is sample size calculation for observational study. Uh, for observational study, okay. For observational study, we need four parameters: precision, expected prevalence, confidence level, data variability. But for interventional study, we don't have precision, we will have power. So whenever the effect size is minute or very small, you will increase the power. So we have seen in G power also how to calculate the sample size for both observational study and how to calculate the sample size calculation for observational study. Okay. So maybe in future, if you have any doubt regarding the sample size calculation, you can message me in my mail ID. Okay, I'm providing my mail ID here. So in your future, if you have any doubt regarding the project or any assignment or any thing, if you want additional detail, you can contact me through this mail ID. Okay. If you have any questions, you can post now. Otherwise, we will close the session. Okay. No. For pilot study, 10 is fine, Pragna. You can select 10 or it is fine because it will not have major impact. Okay. You can't select 50 or 60, right? Because if you collect 50 or 60, it won't be like a pilot study. Just take 10, it is sufficient. Don't take like 2 or 3. Maybe take like 10. Okay. But even if you take 10 or 15, that it won't have any impact in the result. Okay. I would say take some 10 samples and then collect the prevalence. Okay. But for example, if it is rare disease, if your disease of interest is rare, uh, even 5 to 7 is fine. But if your disease of interest is No, 1 minute. If your disease of interest is very frequent one, so it is based on the disease of interest, right? So for example, see, if it is rare disease, for example, if you want to find the prevalence of rare disease like HIV, then you may require a large sample. Okay, even if it is pre pilot study, you may need a larger sample because HIV we will not get very frequently, right? But if it is a very frequent disease like flu, if it is cough, very frequent, then 10 is sufficient. But if it is very larger, if it is a very rare disease like HIV, then you may need like 20, 30. You need more number of subject till you get the HIV patient. Okay. So it depends on the type of disease you are going to explore. Okay. But if it is a very frequent disease, keep it as 10, like flu, cough. You can keep it as 10. That is sufficient. Okay. 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 Okay, you are asking how to calculate sample size when you have more than two groups, right? Okay, so there is something called ANOVA. Okay, so ANOVA is a statistical test. When you have a more than two groups, the test we will use it as ANOVA test. But here we don't have the ANOVA test. So you can use other software. The test name is ANOVA. So ANOVA is a statistical test when you want to compare more than two groups, like two experimental and one control group. But I think you can use some SPSS software. Okay, maybe, yeah. So you can use SPSS software in that case if you want to compare three groups. Okay, the test name is ANOVA, analysis of variance. Okay, I don't think here they have this test. Here they have only F. Yeah, I think they have F test. Sorry, they have a F test. Sorry. Yeah. 1 minute. Yeah. Okay. So what you have to do is whenever you have more than two group, select F test, and then okay, what you have to do is select ANOVA. Okay. So when you have more than two group, it is one way, it is ANOVA, and then we have to give the input. Maybe I will come back to you through offline. I will little bit explore. I didn't explore this ANOVA. I have explored only two group. Maybe you can contact me in chat. I will tell how to calculate the sample size for two group. Okay. But the test name is ANOVA. Okay. I will just go through this option and I will come back to you. So when you have two groups, you will use the T test. When you have more than two tests, you will select F test. Okay. Any other questions? Okay. If there is no other questions, we can close the session. Ajit, do you have any remarks? Okay. I think if there is no other questions, we will close the session now. Thank you everyone for your time. If you have any questions, you can contact me in okay, I think. Okay, Bhavana, she has some question. In interventional study for comparison of new drug with existing drug, how to calculate the okay. So I think for example, the Pfizer is the first company, right? So Pfizer is the first company to develop the COVID vaccine, right? So at that time, there won't be any comparative vaccine. What they will do is they will check the comparative of Pfizer vaccine and effectiveness of placebo. So what they will do is there will be a lot of doctors and researchers involved in the COVID vaccine development, right? They may know what would be the expected effect size. So they won't do any pilot study. What they will do is they will the expert or the people who worked on doctors or researchers, they know the molecular level of COVID vaccine. Also, they know the what is the effectiveness of placebo. Placebo is just an inactive substance, right? So they will guess the effect size by the knowledge. By their knowledge, they will guess the effect size. Okay, so it is based on the expert opinion. Okay, so when there is a no comparative drug, what they will do is based on the expert opinion, doctors or researchers, the people who worked on the COVID vaccine on a molecular level, they will they will decide the effect size. Bhavana, you got it? Okay, you are welcome. Okay, is there any other questions? Okay, if there is no other question, we will close the session. Thank you, everyone. Don't hesitate to ask me in a chat, mail. Happy to collaborate. Thank you, everyone. Have a nice day. Bye. Thank you.